Hello, I'm Krishna, and I will be introducing a LANO application called B. And this talk is about how we orchestrate workflows with containerized applications leveraging Charliecloud. So this is the current B team, and then we have our contact information. If you have any questions about the application, you can reach out. So the agenda is I'm going to give you an introduction to B, and then I'll explain why we have a B there. And then I'll move on to the Charliecloud implementation integration, and then I will give a demo. All right, so intro to B. B stands for Build and Execution Environment, and it is a workflow orchestration system for HPC applications or HPC workflows. So some of the key things about B is it is designed for HPC simulations. We provide NPI support, checkpoint restart capability, and we're able to manage multiple workflows at the same time. B also supports multiple compute resources for both HPC and cloud. There's no privileged access required, which is the reason why we use Charliecloud for any of our unprivileged builds and container runs. We also use the open standard workflow specification common workflow language. We do currently have a Python API that can create these common workflow language files. So it just makes it easier for more people to use B. We also have automation. What we mean by this is that we are able to create a configuration file related to your platform. So all of the setup, it will be ready for you. And reproducible workflows. So you're able to run your workflows, they will be archived, and then you can always go back to check everything that was done, and then you can rerun it. So this keeps track of provenance of all of your workflows as well. So now I'm going to talk about all the B components. So we start with the main client, and then what we're going to do here is we're going to have a CWL of your entire workflow. It's going to be fed into the client. We're going to parse it, and then we're going to distribute everything from there to different components. So this will go to the workflow manager, and then we use the Neo4j database to manage all of the tasks within each workflow. So this is where we have the task manager. Now for the task manager, we have three different components. We have a builder that is going to build a container if the specific task requires a container. And then we have the container runtime, and this is going to run said container. And of course, we use Charliecloud. Now, B is very modular, so we are able to support other container runtimes as well. And then we have the worker. So this is going to handle, it's going to do the job scheduling. We have support for both Slurm and Flux, but our default is Slurm. And everything is done in Python. All right, so let's talk about that configuration file. Now, we're going to, on your terminal, you're going to do bflow config new. Now, one thing I'm going to point out is this bflow word. So the name of our project is B for build and execution environment, but our command line tool is called bflow, and it's B workflow combined. And that's why we use B's as our logos. So this bflow config new command is going to create the configuration, the initial configuration file. And so now I'm going to go into details of what that's going to look like. So we have our first block is going to be the default, and this is going to set up the paths to everything that we're going to need later. So we have here, you can specify your workflow scheduler, and these dependencies, these are for our database. And then we move on to the task manager. We specify that the container runtime here is going to be Charliecloud. And then you move on to Charliecloud specifics. So your mount directory, and then some options for chrun. And again, these are all default values. This is the job scheduler information. The default is all empty, but you can modify it. And then this is for our graph database, and then we move on to our builder step. And we can specify the container type for the builder, and that would be Charliecloud in this case. And then everything related to Slurm. All right, so Charliecloud integration. So we go back to that CWL file. Now for this file, we have a requirements section. And so I will focus on the task manager, the builder, and the container runtime here. These are all of the options that you have for this requirements portion. I'm going to focus on Docker requirements. So you have people, you have MPI, checkpoint, scheduler, and the script. These are related to our worker. So again, Docker requirement will set up everything within the builder and the container runtime. This is an example of a Docker requirement. Now this is specific to common workflow language. So you need a Docker file. And then we have a specific sub option, which would be the bflow container name. And then here you have more options, more sub options. So this top part, this is all specific to CWL. And then this part below, these are sub options that we have added just to manage the container a little bit more. So let's do an example. The example I've chosen is a Clamor FFmpeg workflow. Clamor is a LANO-specific mini app, and it simulates shallow equation or shallow water equations by doing a cell-based adaptive mesh refinement. Then you can find it at this website. Okay, so these are all of the files necessary to run this workflow. We start with the main CWL, so this is going to give us the entire workflow that we're going to run. And this is not the entire CWL, it's just these steps. So we're going to see that we have two main steps. We have a Clamor step and the FFmpeg step. And what we're going to be doing is, for the first step, we're going to run that adaptive mesh refinement simulation, and it's going to produce graphic images from periodic time steps. And then if we look at this Docker requirement part here we're saying, hey, Charliecloud, we want you to build this container, the Clamor FFmpeg container. What's going to happen is that when Charliecloud builds this container, it's going to create a tarball, and this tarball is going to be stored in a container archive that we specified in the configuration file. So for the second step, when we run the FFmpeg tool, it's going to create a movie visualizing everything from the previous step. And we're going to ask it to use the same container, but this time we're not going to build it again, we're just going to pull it. The rest of the file, so we have the Clamor job, that YAML, that only has the values that we're going to need. And then we have that Clamor.cwl, and that's specific to the Clamor step. And then the FFmpeg.cwl is specific to the second step. So now we're in terminal mode. So let's start in a clean work directory. So here I have this Clamor FFmpeg build that contains all of the files I'm going to need. We're going to do a bflow core start, so we're starting an instance of bflow. You can check the status of all of your components. And so everything should be nice and running. And then if you do a bflow list, it's going to list all of the workflows that you're running or that ran and are now archived, or if anything failed. If you do a ch image list, you're going to see your containers, and it's empty. Now we can move on to submitting the actual workflow. So here we have the bflow submit command. and it starts by stating the name of our workflow and then the directory of where all of our files are. And then you're going to give it the main clamor CWL, followed by the YAML with all of the input values. And then there's a dot at the end, and that's just using the current directory as the working directory. Okay, so the workflow is submitted and you get an ID. If we do a bflow list again, you're going to see that your clamor example workflow is now running. And then you can use the query command with the ID that was assigned to your workflow earlier. And this command is going to list the tasks within your workflow. So now I'm just going to show you the different status states that we offer. So we're waiting, and this is not a live demo, so you can't see how long it would take, but the clamor step will take a little longer because we're building that container. So it's running, it has completed. Oh, it has completed, so let's check what's going on. So here we have our scripts, our error messages, and std out. Then if we query again, now the next step is running. Again, it's not going to take as long because we're just pulling that same container. Okay, so now both steps have completed, and then you see above it says archived. So everything is archived and sent to a different directory. A bflow list. Now let's check our archives. So now we have a tarball. And then here are all of our files. So now we see that we have a new directory, which would be the graphics output. This is going to have all of the graphics from that very first step. And then we have the clamor movie, and it's just a movie of all of those graphics from that first step. Let me show you our script, what's going on in the background. So it starts with all of the Slurm stuff that I'm going to skip. Okay, and then so what bflow is doing is it makes a temporary directory. It checks, or it uses Charliecloud, so chconvert, to convert that tarball that is created when it builds into a directory. And then we use chrun to run our container. And then after the two dashes, you can see the clamor simulation running inside of the container. And then I'm going to show you the script of the second step. So again, all of the Slurm stuff going on, and then chconvert to convert that tarball into a directory, and then chrun is running that container, and then this is what's going on inside of the container. If we do a ch image list, we can now see that clamor ffmpeg container that we've been using. Now, one cool thing not totally related is we have a bflow DAG command, and this will create a DAG of your workflow. So you do bflow DAG and then the unique ID, workflow ID, followed by wherever you want it to be, and it will create a directory with all of the DAGs. You can do this at any time of your workflow, when it's running, when it begins, after, like during the process or afterwards. And so this is what the DAG for this specific workflow looks like. It looks a little blurry. So in dark blue, you have your main workflow. Again, you can run multiple workflows at once. In this case, I'm only running once, or one workflow. In the salmon color, it's a different task. So we had the first task, the clamor task, and then the ffmpeg task. We can see that each task required a Docker requirement, meaning they both use containers. In orange, we have all of the inputs. In green, we have all of the outputs. And then in light blue, we have the status of each task. Now, you will see this more bold arrow. That means it's a depends on. So our second task did not run until the first one finished. Oh, and then it beat. Okay. And so here we have the actual movie that the second task produced. And all of our resources, we have our GitHub documentation, contact, and ways of installation. Are there any questions?
So sorry if you already mentioned it and I didn't follow, but when you submit the workflow and then you're checking the status, is there a server running in the background which is trying to track the status? How are you tracking the status of the work?
We have databases that we use. And then we have queues, we have update queues, and we're all in constant communication. And that's how we're keeping track of the status of each task.
All right, so, and these queues which are running in the background, these are all?
They're Neo4j database, and then we also use Chilleri.
Okay, all right.
Yes.
So is the idea that a sysadmin would be like standing up Neo4j or like on an HPC system, or is that basically?
No, it's all vFlow specific. So you don't need somebody else to set things up for you. Everything is within vFlow.
So the user stands up their own Neo4j instance.
I'm sorry?
That the user would basically stand up their own Neo4j instance running on the node.
Yes.
Okay.
Yes, but the user does not need to, like, once you install vFlow, you can just run it. You don't need to, so we have this thing called vFlow full dependencies, and this is where we bring the Neo4j dependency. So it's going to be calling that. So you don't need to do anything extra. When you install vFlow, it will come with it.
Sorry for the detailed question then, but could you then indicate where the Neo4j instance has started? Like when you launch the workflow, where does it start?
Where does it start? What do you mean?
Could you please go to the slide where you launch the workflow?
So we do have this graph database in the configuration file, and these are all default values.
All right. And then could you go to the next slide where you launch the workflow? Yeah, here, I guess. Yeah, okay. Right, so vFlow core start would then start this database as well.
Yes.
All right.
Yes, so
Yeah.
it starts up all of the components. Yes.
Yeah, so I saw that there's like a checkpointing capability also. And then I was reading the vFlow documentation. And so what the checkpointing does is if your software has the checkpointing feature, it'll sort of track those files and restart from those files.
Yes.
So it's just kind of tangential, but I really want to know what you guys use for checkpointing at Lano, because I've tried many checkpointing libraries and like it's painful. Like even Boost serialized checkpoint, which should be XML, it doesn't always work across machines, and so.
Okay.
So I'm just kind of curious what checkpointing program that you guys use that you find reliable and meets your needs.
I don't know if there's a specific one that all of Lano uses. So I also don't know if vFlow uses a specific one, but I'm not sure what we haven't touched the checkpoint capability in a while, so I don't know what was used back then. So I'm not sure how to answer, but I don't know if Megan or Reed knows of one that the rest of the lab uses.
Yeah, because there's a couple out there. I think there's PLCR, but that requires kernel support. And there's one out of Northwestern, which uses, like it hijacks some of the Unix signals for its work with this very limited number of those. And so that doesn't always work for all clusters. Yeah, so.
No, that's a good question, and I should know this. So I will find out if you ask me another time.
Okay.
I'll know an answer.
Yeah.
Any other questions for Krishna? Or just Charliecloud in general, I guess, since we're kind of getting into office hours portion. So any questions on anything?
So I guess I have one question. So you're signing up a lot of services, right? Like I would imagine this is on a log node, and when you have jobs that kind of transcend the node boundary, like let's say multiple nodes, I know Charliecloud is pretty clear, can run happily as one. So in these use cases, like more of a systems question, you see any issues where they can't talk to the database, or there are some restrictions that the system itself throws at you? Do you have to work with any such restrictions, or is that something that you have?
No, not really. So the good thing about vFlow is that we integrate a lot of different technologies. So if you're already using Slurm with something else and you're doing the same thing within vFlow, then that will work. So if you're already using Charliecloud, whatever you can do with Charliecloud, you can bring it over and use it with vFlow. So it's I haven't encountered any problems there.
Yeah, you're building on top of it.
Mm-hmm.
Yes. Yeah, I run into some bioinformatics workflows that do a lot like this, but obviously they're not containerized, and there's some interesting issues. Thanks.
Anything else? These are all great questions. Oh, I think you're good, Krishna. You can plug.